So for anyone who has the Raspberry Pi kit ready and installed the operating system, let's walk through the software install for Portal machine projects. I'm able to remote log into my Raspberry Pi operating system. So after you installed, follow the steps which Felix introduced, you will see this screen for the Raspberry Pi. And if you are not connected to the Wi-Fi, so on the top right corner, there's a Wi-Fi button here. You can connect to your Wi-Fi and maybe ask your parents' help to enter your password. So you can connect to the Wi-Fi. After you connect to the Wi-Fi, in the Raspberry Pi, it has a web browser. You can open the web browser here. I'm going to go to our guide. If you in the browser type into cie-dfw.org, will bring you to our project website. If you are on the OS system, please try this as I'm walking through this. And this is our 2021 SECC event. So click on this link. We will brought you to our event page. In the event page, you scroll down to the bottom, we have a project instruction document. I'm going to open that document. Project description, if you click on this link, you will download a Word document. But in Raspberry Pi, it's not a Windows system, it's a Linux system. So when you open this file, it's actually have a LibreOffice within this operating system, but files still can open. So once you open this file, we have the project introductions. Let me make this bigger. I hope many of you already look at this project document before. We definitely add some other resources for you so we can try this Portal machine project and also the creativity projects. I'm gonna skip this introduction part, which is introduce the equipment we need and a brief introduction about the Raspberry Pi platform. So the demo videos, we have some demo videos available in this document too. The Raspberry Pi introductions, the setup, the operating system setup, which Felix just introduced. Those are YouTube link for you to check if you haven't received your Raspberry Pi kit yet. Now I want to go to talking about how we can install the Portal machine packages, software packages. So in this step, we have a software install guide, and we have a GitHub site available for you. If you type your keyboard control, then use your mouse left click on this link. It will bring you to our GitHub site with our Portal machine software install guide. I will pause a little bit here. So in this site, we have a lot of reference, how you can build their Portal machines with the server motors and the wiring instructions, calibrate tricks, and some other resources talking about the pin out or pin about the Raspberry Pi. What I'm going to try here is we want to make this software install easier for you. So we create one command. If you are at this page, just copy this link right click, click copy. And on your top left corner, in Linux system, we have a terminal option. If you click this small icon, we call terminal, you bring up the terminal for your Raspberry Pi system. Basically, this is the terminal. Terminal basically you can think about it's a backend, or you are actually hacking into your system, because you can look at all the file systems through the command, but not through the file system. We do have a file system here. If you click that, the file manager, you can see all the files available in your Raspberry Pi. Basically, in that SIM card, you just put there. But from this terminal, you can actually access all the files there. So if you copied this link in our GitHub site already, now we just need to paste that into our terminal. And you right click and click paste. Then you hit enter. It will start to install all the packages needed for our plot machine projects. Okay, so we have all the packages installed, but if you are first time install all the required packages, it will take us maybe 2 or 3 minutes. The next step, we provide some examples you can try how the graph is working or plot machine is working. Since we haven't set up the servo motors, we'll talk about that part later, but I want to show you how we can try some image printing through the terminal. So on the GitHub instructions, we have this example, draw a map, which is taking the Africa GPG, that picture, and convert that to images which the plotter machine can understand, or your servo motors can understand. Basically, you just copy the first command. Go to your terminal, right click, paste. Then copy the second command, right click, copy, go back to your terminal. Hit enter. You will download the Africa mapdraw.py. It's a Python program which will start or can use that Africa picture and convert it. Now we copy the third command and type that into our terminal. Now you will see the program start to processing the pictures. It's finding the edges of that picture, and then start to convert the picture to many dots, which the servo motor can understand. I will pause a little bit here, and do we have the chat window open? If we have any questions or have a hard time to follow this. So I would like ask Shuming to help if we have any questions in the chat window.
I see there's one question. Actually, there are two questions from Yihan.
Okay.
One is, what are the websites?
The website, it's the CIE. Wait, so are we asking where to find the instructions, or are we asking where to find the code?
Yeah, I can use this. So we can start from cie-dfw.org.
Yes.
From there, you can start. You can find the division B.
Or we can we actually paste that link too, right, to this 2021 event link.
Yes.
Let me see, where's my, I can put my chat. I didn't see my chat. Shumi, can you help to paste that link, the event link? I think Hua already published, or Marisa published that earlier. So under there, we have a project descriptions. If we click that link, we'll have this Word document downloaded. And in this Word document, the how to build a plotter section, the code is under this 2021 SECC Division B project Git. It's a GitHub we just brought in from on our web page. Did I open a new one? So we brought up this page. This is the instructions. And if you want to install all the software packages, just need to copy this one command, paste that into your terminal, and hit enter. That will install all the packages that needed. And this is one example we want to show how it converts the Africa map into the different lines which the server motor can understand. So once you connect to your server motors for your plot machine, actually you will start to drawing while this start converting the lines. Now, if we go back to the document, I want to out to our GitHub site. We have some references, right? Let's take a look at that. The first one, the build part. I would like to play the video. There's a very good introduction how we can install everything or all the parts for the plot machine. Let me see if I can share my sound. Yeah, sorry. I think I need to stop share and share my sound. Hold on a second. Share screen, share sound. Okay, so if I click this link, the build, it will bring you to the web page, which has a lot of instructions for how the plot machine should be built. And this section, build a plotter, have a very detailed instructions to show you how you can connect all the server motors, the wires, and the wood stick together. So let's take a look at that while our program is running to convert the images. Can everyone hear the sound or no?
I cannot hear the sound.
Yeah, I think it's because I probably play from the Raspberry Pi, but not from the.
Can you open your Windows?
Yeah, I can. Let me stop this. I probably cannot copy this link. Let me try my Windows. So project descriptions, go here. All right, building instructions. Can you hear the sound now?
Yes.
Okay, great. So let's review this short video.
Hi everyone, meet the Brachiograph. This is a cheap pen plotter driven by a Raspberry Pi that was invented by my friend Daniela, who demonstrated it to the audience at last year's PyCon UK. I think a Brachiograph is sufficiently easy to make and has such cool results that it would make a great first robotics project for anyone who wants to get into the hobby, or just anyone with some free time in lockdown. To make one, you're going to need a Raspberry Pi, and any model will do, including a Pi Zero. 3 servos, which I'll explain in a moment, 2 lolly sticks, a clothes peg, a pen, some glue, and I'd recommend a hot glue gun here, a base plate, any scrap wood or board will do as long as it's around 3mm thick, and some way of wiring everything together. A servo is a little self-contained package which allows us to precisely control the angle of its output shaft. The output shaft plugs into a little piece of plastic called a servo horn, which we can then attach to whatever we want. These always come packaged with the servos when you buy them. Inside each servo there's a tiny motor connected to a bunch of gears, which in turn drive the output shaft. The output shaft is internally connected to a tiny potentiometer, which allows the servo to sense what angle the output shaft is currently at. Finally, you have all these electronics in the base, which connect the potentiometer to the motor and allow us to send a signal through an input wire to specify the angle we want. We have 3 wires going into a servo, 2 of which provide power to it and 1 which sends a signal. One final note about these servos: you can get them for less than £1 each, but your results will be much better if you spend just a little bit more. If the Brachiograph twitches or gyres and gimbals in the wave, you may need better servos. Now, we'll assemble the Brachiograph. First, glue one of the servos to the corner of the base plate. You can weight this plate down when the Brachiograph is drawing to produce better results. The lolly sticks are going to form the upper and lower parts of the Brachiograph's arm. Mark out 8cm lengths on each lolly stick. We want these to be the centres of rotation, and we'll use these marks to line everything up. For the upper part of the arm, glue 2 servo horns to the lolly stick. For convenience, drill through the centres of these horns and the lolly stick, so as to attach and remove them from the servo more easily. For the lower part of the arm, first glue a clothes peg at one end to hold the pen. Now glue one of the servos directly to the lolly stick at the other end. Finally, glue a servo to the other side of the clothes peg end. This allows the pen to be raised and lowered depending on whether or not the Brachiograph should be drawing. You can now screw everything together, but you might want to remove and adjust the arms when you come to calibrate it. Now, there aren't quite enough 5V pins on the Pi to drive 3 servos, so we have to make a little wiring loom to connect everything together. I've used a breadboard and some jumper wires to keep everything simple. If you haven't used a breadboard before, you just need to know that all the holes in each row are connected to one another. So if I apply 5V to the top hole in a row, I can get 5V out of all the other holes in that row. The heart of this project is a Raspberry Pi, and that's where we run the Python code to drive the Brachiograph. One of the wonderful features that's common to all Raspberry Pis is the big pin header, which lets us connect up our own electronics. Some of the pins provide 5V and 0V that we can use to power our projects, and some other pins, called GPIO pins or general purpose input-output pins, let us send and receive digital data. For the Brachiograph, we're going to use 5 of these pins to connect our plus 5V, 0V, and 3 GPIO pins for signals 1, 2, and 3. Using jumper wires and the breadboard, we connect everything together so the Pi can talk to the servos.
This part I want to mention that you can actually, when you view this video, this graph will help you to wire your servo motors to your Raspberry Pi. Let's continue.
That's it. You can now use Daniela's software to calibrate the Brachiograph and start producing your own works of robot art.
Okay, that's the short video on our instructions, which you can reference this website. One thing I want to mention that in here, we have the install software, all the different steps. And in our guide, we actually made that simple for you, which you just need to go to our GitHub site to run that one command. So all the software package will be ready for you. Now let's go back to our terminal. So it looks like our ethical draw is finished. It's done. So what I want to show you is if you go to our file system here, or file manager, we have this Brachiograph, which downloaded as a software package. And if you click into this file, images, we have this Ethical GPG, which is what we used for this example. And after you run this Python code, ethical map drawer p.py, it converts these images to the SVG images. If I open these images, you'll see that's the graph you're going to draw on your plot machine when it's finished. This is we convert the ethical map into this line and dot. Let's compare that. This is the actual images, and we convert to this SVG file. And if you're interested to see this JSON format, this is actually how the program or how your code convert that to tell the plot machine. Let's see whether we can see that. Yep, it's very small. If you imagine that the server motor cannot understand the graphic, right? So the program actually convert that into different dots and tell the positions to the motors and to draw the different lines and dots to finish that graph drawing. And if you didn't follow this today, don't worry. We have record this video. And also do remember, go to our project instructions to look at all the references, and also on our GitHub site. From our project documents. And follow through our GitHub site to install the software packages. And one of the example I want to mention here is the last part, download a photo and draw. So in this plot machine project, we are requested to draw 3 pictures. You can simply replace this link with your own pictures and run this code one by one. So that will draw the pictures, whatever images you put in this link. You can reference that and replace this part. And just run the last part. Will help you to draw the pictures, any pictures you want. And let's go back to this terminal. One thing to check that GPIO pin, you can just simply type pin out in your terminal. It will brought up how the pin relate to your Raspberry Pi. That's a simple command. You can reference with this ground line. And those output, I think in plot machine, they use this 5 volt, the ground, and the GPIO 14, 15, and 18, those 5. Be sure to check the video, and also you can use the shortcut here, the pin out, to get what the setup on the Raspberry Pi pin numbers. While I'm sharing this, I want to mention that traffic light project, we mentioned the Scratch. So if you install the operating system, this Scratch 3 is already in the Raspberry Pi. So in here, there's a berry button or icon. You click on that, go to programming, and you have a Scratch 3. You can click that and it will be open on your Raspberry Pi. In order to play with the electronic components, if you are familiar with the Scratch and you don't quite familiar with the Python code, don't worry. This Scratch in the operating system can help you to control those electronic components. I'm going to show you how you can try by yourself. So once you open the Scratch, let me see. On the left corner, there's a button called Add Extension. You click on that. You will brought up some extensions, right? You can do the music or pen. What we want to use is Raspberry Pi Simple Electronic. You click on this one. You brought up this in the Scratch, all this green command, which can tell you or help you to control electronic parts. For For example, you're working on the traffic light project. Let me make this bigger so we can see that. So if you connect your resistors and also the light on your breadboard, there's numbers here. These numbers is related to that GPIO output. So for example, I want to control the light, or you connect to the light to the 5 GPIO pin, and this one can turn that light on. And you have some other, like you can put the sound, or you put other controls, right? Wait for like 1 second, and then turn that off. Basically, you can choose turn the LED light off, and also apply to that 5 number. Okay, that's the basic walkthrough for the Scratch, which you can use, and it's very fun to play because you can control the animation here in the Raspberry Pi operating system. Another very good resource is for your to start some simple projects is to go to the Raspberry Pi org to find some projects or introductions to play with it before you start to do some more complex projects. So on our instructions, we also provide the link, Raspberry Pi project ideas. If you click on that, it will bring you to this awesome site. It has a lot of Raspberry Pi projects you can do. And it will have very detailed instructions. For example, if you want to build a line following robot, it has what you need on this website and has instructions how to build it. So we highly encourage you to go to this website to try some simple or projects to get familiar with the Raspberry Pi. And as for the Proton Machine projects, if you have any questions about hardware setup or the software setup, you can send the emails to us, or in the next Q&A session, you can type the question in the chat window. We'll help to answer that. That's the end of my demo. So we are open for the questions.